Anika and Beth are playing a game, and either Anika wins the point with a probability of 0.7, or Beth wins the point with a probability of 0.3. There's no draws in each game or point. The outcome of each point is then independent of the outcome of every other point, so they don't affect each other. And the first player to win 2 points wins the game. Write down the probability that the game consists of more than 3 points. Well, that is going to be 0 because after 3 points, one of them must have won at least 2. Complete the probability tree diagram showing all the possibilities for the game. So here's one that I've started earlier. This is the first game, and then we've got the second game. So I'm just going to say A for Anika wins, and then B for Beth wins, and it's still going to be 0.7 and 0.3. Now, if Anika wins here, then we stop actually, so the tree does not carry on. But if Beth wins, then there's a third game. And similarly down here, this time we stop if Beth wins 2 in a row, but if Anika wins the second game, we have a third game again. Now, determine the probability that Beth wins the game. So Beth wins the game by either just winning 2 in a row, that's going to be 0.3 squared, or Anika wins and then Beth wins 2 in a row, or Anika wins, sorry, Beth wins, then Anika wins, then Beth wins. Actually, you still get 0.3 times 0.7 times 0.3 here, so I can just double this. And if you work that out, then it's actually 0.216. For part D, determine the probability that the game consists of exactly 3 points. Sorry, I didn't draw a little. Let me just draw that little arrow. So these red arrows are where Beth wins the game. Okay, exactly 3 points. Now that's going to be when we have 3 little branches on our tree. So these 4 here. So you could work out these 4. In fact, we've already worked out 2 of them. Or you can do 1 minus the other 2. 1 minus 0.3 squared, that's when Beth wins twice in a row, minus 0.7 squared, that's when Anika wins 2 in a row. If we work that out, then we get 0.42. Finally, we're told, given that Beth wins the game, determine the probability that the game consists of exactly 3 points. This is a conditional probability question, so I'm just going to make a bit of space for it. So the probability of x given y, quite often in the formula book it's a and b, but I'm avoiding that here because we've already got a for an Anika, and I'm just talking about general events now. Right, this is equal to the probability of a and b, so the intersection, divided by the probability of b, sorry, not a and b, just in the habit of doing that, x and y divided by the probability of y. Essentially, we know that y has happened, so we just like cross off all the other ones when it hasn't happened. And then we're interested in x and y happening, but dividing by this reduced sample space probability because everything else is gone. That's a very quick overview of why this works, but I do recommend you read up on it and understand it. So for us, it was the probability. I'm just going to read it out again. Probability of 3 points given that Beth wins the game. Therefore, that's going to equal the probability of 3 points and Beth winning divided by the probability of Beth winning. Well, the bottom is straightforward because you've already worked it out. It was that 0.216 from before. But the probability of 3 points and Beth winning is going to be this one here and this one here, but not the one here from before. So in fact, it's going to be this 2 times 0.7 times 0.3 squared. And that's it. As long as you carefully work through it and use this definition, it's not too bad. And if you work that out, so I've got it written in front of me, so I'm not going to put my calculator here, it is 7/12. Well done.